Welcome to section 2, where we'll build the API skeleton. A walking skeleton is a minimal initial implementation of an application's architecture that includes and connects the basic components of the system. The API skeleton is a simple web API which returns a collection of surveys as JSON. I'll use Visual Studio Code for this section instead of Visual Studio. Opening the environment, I'll select File, Autosave, and install some extensions, including C# for Visual Studio Code by OmniSharp, C# extensions by JOS Creative, and PowerShell. Building the application, the first step is to build a .NET solution containing a class library project and a web API project. There's a PowerShell script for this in a resources file for the course that can be downloaded from javaconsult.co.uk/reactsurvey.zip. Extract the file and open the React Survey folder in Visual Studio Code. This contains a script .NET.ps1. I'll declare variables for the name of the solution, the class library project, and the web app. Opening the documentation, variable names are prefixed with $. Select these lines and hit the F8 key to run that part of the script. Next, we can use the new command to create the solution. Opening the .NET CLI documentation and clicking New, you can see the templates that come pre-installed with the .NET SDK. These include class lib, web, and SLN. Select these lines and then press F8. Next, I'll add the projects to the solution, change to the web project folder, and add a reference from the web project to the class library project. Selecting these lines and pressing F8 runs that part of the script. There are a number of NuGet packages that we need to add to these projects. Using the .NET CLI, we can use the add package command to add entity framework packages to the class library for SQLite and SQL Server. Changing to the web app project folder, we can add these packages to the web project. Next, I'll use the git init command to create an empty Git repository at the root of the project and also create a gitignore file. Gitignore specifies files that aren't included in the Git repository. To generate the content, I'll open the gitignore.io website, type in .NET Core, and add this to the gitignore file. To start the application, I'll use the .NET Run command. .NET Watch is a tool that runs a .NET Core CLI command when source files change. So .NET Watch Run will reload the application when the source code changes. We're specifying the path of the project file to run and the name of the launch profile to use when launching the application. Launch profiles are defined in launchSettings.json, which is in the web app's Properties folder. This sets the development server URL. Opening the weather forecast controller file, the root to this sample controller will be /weather forecast. Using token replacement, the controller argument is replaced by the controller name. A GET request returns an array of weather forecast objects as JSON. This can be seen more clearly in Postman. Next, I'll write the survey class. I'll open the solution we built earlier using Visual Studio Community Edition. The API skeleton returns a collection of surveys as JSON. We can define the survey class in the class library's entity folder. I'll define this as a public class containing properties, ID, name and description. C#8 introduces nullable reference types. These are declared by appending a question mark to a type. A non-nullable type should be initialized, otherwise you can see there's a warning. The GUID struct is in the system namespace. Add a global modifier to any using directive to instruct the compiler that the directive applies to all source files in a project. Projects include an auto-generated file in the obj folder. If I click Build and then Build Solution, I can click on Show All Files, open up obj debug, net6, and you can see the global usings is here. The list of global usings will depend on the project type. The next step is to create a class that derives from DB context. I'll add this to a folder named repository. A DB context instance represents a session with the database and can be used to query and save instances of entities. The constructor forwards a generic dbContextOptions object to the base class constructor. We'll configure this in the program class. A dbSet represents the collection of all entities in the context, or that can be queried from the database. The DB context is added to the web project's service collection in program.cs. Add DB context is a generic extension method of iService collection that takes a delegate argument of type action. The action encapsulates a method that has a single parameter and doesn't return a value. It's used to configure the DB context options for the context. Use SQLite is an extension method of DB context options builder that takes a connection string as an argument. The connection string is read from appsettings.development.json. Moving on to migrations, as the documentation says, the migrations feature in EF Core provides a way to incrementally update the database schema to keep it in sync with the application's data model while preserving existing data in the database. The Microsoft.Entity Framework Core.Design package contains the design time logic for Entity Framework Core, including migrations. Opening the migrations PowerShell file, I'll run the .NET tool install command to install the CLI tool for EF Core. You can see that it's already installed on this PC. The .NET EF migrations add command adds a new migration. The P option indicates the target project where the migration files will be added, and initial will be the name of the generated class. The S option indicates the relative path to the startup projects folder. This is the project that contains information about the project, such as the database connection string and the configuration of the model. This generates a migrations folder containing a class with a create table method. We can run this method with the .NET EF database update command, which updates the database to the last migration or to a specified migration. You can see that's created the surveys table. You can see that there's now a file, survey.db. We could view this in an SQL-like browser. I've installed a browser called DB Browser for SQLite. So, opening the database, and then database structure. That's the surveys table and the columns. We can add some data to this table. Going back to the assets folder, there's an add surveys script. So I'll copy the SQL and back in DB Browser, select Browse Data, execute SQL, paste in the script, and then execute. I'm going back to Browse Data. We should now see the content. So the ID is a GUID, and then we've got a name and description. Next topic is the application architecture. This follows the controller service repository pattern. The controller provides a REST interface to the client. The service layer handles business logic, and the repository layer interacts with the database. A benefit of this separation of concerns is that layers can be tested in isolation using mock objects for adjacent layers. Dependencies between layers are injected. The survey controller has a dependency on iSurvey service, which is implemented by survey service. Similarly, survey service has a dependency on iSurvey repository, and survey repository has a reference on survey DB context, which we built earlier. This dependency injection uses the iService collection object configured in program.cs. Starting with the repository layer, which interacts with the database, I'll add a class named Survey Repository to the repository namespace. The selectAll method gets the surveys properties from the survey DB context, which is in an IEnumerable, and converts it into a list. If a constructor can be implemented as a single statement, you can use an expression body definition. Extract the interface, iSurvey repository, by clicking the screwdriver symbol to the left of the class. The service layer handles business logic. Add a folder, Services, to the web project. This contains a class, Survey Service. Inject a reference to iSurvey repository and add a method that calls the repository's selectAll method. Then extract an interface. The controller provides a REST interface to the client. Add a class named SurveyController to the controllers folder in the Web API project. This derives from controller base, which is a base class for an MVC controller without view support. The API controller attribute can be applied to a controller class to enable API-specific behaviors, including making attribute routing a requirement, automatic HTTP 400 responses if the isValid property of the controller's model state in an action method is false, and binding source parameter inference. The fromBody attribute is inferred for complex type parameters. The root attribute constructor takes a root template argument. Controller in square brackets will match the controller name, so API/survey in this example. We'll use dependency injection configured in the program class to get a reference to iSurvey service and add a method that responds to an HTTP GET request and returns a collection of surveys. The next step is to configure dependency injection in the program.cs file. Starting in C#9, a console application project can be written without explicitly including a main method. The compiler generates a class and main method entry point for the application. The iService collection's addTransient method associates an interface with an implementation. Each time a transient service is requested, a new instance is created. The func argument describes a factory for building the service. The func t result delegate encapsulates a method that has one parameter of type t and returns a t result. Func iService provider object encapsulates a method that takes an iService provider argument and returns an object. iService provider has a getService method that we're using to look up the survey DB context that was added to the service collection earlier. We're passing this into the survey repository constructor. An overload to the addTransient method associates an interface with an implementation. This enables a constructor that takes an iSurvey service argument to be automatically passed a survey service object. We should now be able to check if the application works. Opening the .NET.ps1 file, .NET watch run restarts the application when it detects changes to watched files. Launch profiles are defined in launchsettings.json. This specifies the HTTP port and the ASP.NET Core environment variable. Opening Postman and browsing to that server port /API/survey, you can see that the GET request returns a JSON response.